This is mix mode. Let's dig in the Bleep Drum. It's an 8-bit Arduino drum machine with 4 samples, a sequencer, a MIDI input, and a DAC. Let's have a look at the schematic. We're going to use an Arduino Nano. What this provides is the microcontroller, a USB interface, so it's USB to serial converter, so that we can very easily program it and power it because there's a regulator as well on this board. It's the core of the circuit. We have our 2 pots. They're wired as a resistor divider between 5 volt and ground, and the wiper just goes straight to an analog pin, in this case analog 0 and a 1. We're using linear pots, and the value read doesn't matter. You can use 5K, we use 10K here, but if you've got 50K or 100K, it's the same. Then we have 2 sets of 4 switches. Here we've got the 4 trigger switches, which are like big as tack switches, but you can use whatever you want. And they're just wired straight from a pin using the internal pull-up resistors of the 80 mega and ground. And it's the same for the other one, just straight from a pin to ground. We also have a MIDI input on this circuit, and this is very standard. You have an optocoupler, a small protection diode, and a small series resistor here. This uses a standard MIDI pinout on a TRS jack, and then on the output of the optocoupler, this is basically providing biasing, and you've got a pull-up resistor, and then that goes to the RX1 pin on the Arduino Nano. We also have an RGB LED, which I haven't got on mine, but you can put it on. And there's our DAC. So this is an MCP 4801, which is a mono 8-bit DAC. We've got a very simple RC network on the output. So there's this C5 here is just for decoupling, and R10 provides our output impedance, and R11 is our load. And I happen to have a stereo version of it when I was building this, so I worked that in and added the second output. That's about it. That's all there is on this on the circuit. There's really not a lot. And the way I've built this, I used pad per hole boards, some tin copper wires, some single core wires that's insulated for when I need to cross. Got a couple of 9mm pots, some big tack switches, some smaller ones, and then here we've got our optocoupler with the MIDI input, and the DAC is here with the output there, and the Nano is wedged in between. Right, so all of this is available on Bleep Labs GitHub. He shares a lot of his stuff. Most of it is open source. He's got loads of repositories with really cool stuff. You should check it out. And you can just get the code for the Bleep Drum. It'll work more or less out of the box here. Although I've made a few pin swaps, so I did create a fork of it. So one thing that's pretty cool about this is that it's all Creative Commons Share like 3.0, which means that you can use it, you can modify it, you can even use it in a commercial way if you want to. You just need to mention Bleep Labs, and you need to share it as a Creative Commons. So that's pretty cool. And we're going to have a quick look at the code itself. In the Bleep Labs repository, we have 2 folders. There's the Bleep Drum and the Damn Drum. It's basically the same thing twice, but we've got different samples. There's a couple of really minor differences in the code, but it's very, very similar. So the way this is set up, in Bleep Drums 12.ino, you have all of the variables, basically all the initialization of everything, all of the samples, the accumulators, the increments, sequences. Yeah, there's loads in there. It just sets up all the pins, debouncers for the triggers, handles MIDI, and most importantly, it sets up a timer to trigger an audio interrupt. What this does is it's going to set up a timer at something like 15 kilohertz. And every time this timer overflows, it will trigger this interrupt. And what happens here is that we're going to go and read our sample, sum that, and play it back on the DAC. The other thing that we do is we increment all our accumulators. The accumulator is a counter that tells us where in the sample we are. and what do we need to play next. And that's about it. And then you've got our main loop, which does all of the interaction with the actual device. So it's going to go and check if we have MIDI coming, whether we pressed any switches. It's going to read the parts. It's going to update the LED. All this kind of stuff happens here. And it also handles the sequencer. I'm going to give you a little demo. So we've got 4 samples. A kick, a snare, some kind of synth or bass or something. And in the Bleep one, we've got a little clappy thing. Sometimes it's a hat. It depends on the set of samples. And basically, you can play it. And you can sequence it as well. So press shift and then select the sequence. Then you press play and record, and then you can go. And we'll just play it back. And you can record basically anything. We record the position of the pots as well for these 2 guys. There's a reverse mode, so if you press shift and play at the same time, it will reverse your samples. And the pots control the playback speed of the top 2 samples. So you can basically make it faster or slower. And what I've added is that you can press shift once, and then that now controls the bottom row. So you can detune your snare, I could like that, and then, yeah, that's fat. And then you can go. Just like that.